Jay, may I share a slide a minute?
Sure, David.
We talk about avoidable lost time. And I think one of the problems we have in the industry is we have a focus on drilling optimization, faster ROP, faster connection time. And while that's a nice outcome, I think one of the dynamics that we need to consider in the industry is how much money we're actually wasting as a result of some of these incidents. Stuck pipe, lost circulation, kicks. Offshore, it takes days to recover from a simple kick. So if we're proactive and if we're identifying part of these issues moving forward as they evolve, you know, one of the things we always hear is too many alarms, too many nuisance alarms, too many whatever, too many unidentified alarms. Well, the issue is until they're corrected, that's exactly what's going to happen. So what our TAS is allowing us to do is, from first watch, begin to identify those issues. And it's important to understand that once they're corrected, then all those other alarms go away. So that is also the importance of proactivity, is it allows us to eliminate those deemed nuisance alarms. And you know, on just some wells we've looked at, I mean, we have first watch to identified action anywhere from 6, 12, 18 hours. And because we have to understand that the physics of the wellbore is what dictates the stability of the wellbore. And when we're beginning to read those, if you will, sum of forces out of balance in the trends, that's how we're able to identify part of the watch issues. So what it then becomes is our capability to use data in analytics to again proactively identify avoidable lost time. And that is the number that frankly is missing in the industry. We just don't realize how much money we're actually losing in that quest, that Don Quixote quest of a few more feet per hour. And you know, I can tell you as an engineer that rate of penetration, ROP, is only fractional of what the total well time is. So if you improve it a few percentage points, what have you gained if you've destabilized the wellbore? So there are so many issues around this. And you know, the industry talks about automation. We'll never automate wells successfully unless we have a stable wellbore and can sustain it. So that's the importance. And you know, we can show examples on that, and we will as we move along. I can show you on the Oklahoma Prior Trust exactly what happened, where essentially a need for speed governed the practices of the day. So I think moving on, this issue of the importance of proactivity is probably the most critical factor that a lot of systems miss, and it's one that we're committed to resolving.
Well, you make an interesting set of assertions there. One of the things I find particularly interesting is the statement that you made about being able to identify early on and have hours of advance warning. And I'd like to hear someone other perspective on what are the implications of having hours of advance warning. What does that really mean? How effective can that warning be, or does it become another issue of, I guess maybe the better term is alarm management?
You have to look at your reactive time. We don't instantaneously, any information that you're given today, the phone rings, it's instantaneous. We want information. right then, but the reaction time is not what you have. When you go to brake on a car, you have a reaction time going from there. It's longer in the car. When we go into well control training, they speed it up 300 times right there. Well, on a rig, when you're out there, you've got so many motions around you, so much input, that your reaction time is elevated. So by the time, if you're in a reactive situation, you're continuing that hazard for a length of time. So if you've got a hazard here, if you know about it here, it doesn't become a hazard. It's already become, on the reactive side, it's already become a hazard.
So you effectively have the time and the ability to mitigate the hazard from becoming really a hazard that costs you money.
Exactly.
That's impressive. Jeremiah, I know you've worked in a number of real-time centers, and primarily your work was involved with operations that were offshore.
Right.
Can you draw a parallel between how much it means to an offshore operation from your experience in the real-time centers and the length of time it takes to have a reaction using reactive systems versus having a system like we're talking about here?
Definitely. So, for example, when I was working on a certain offshore project, we had around 10 resources that were dedicated to monitoring 5 wells. Each of those guys would monitor 2 wells each, 12-hour shifts, working 14 days on, 14 days off. I was there just to make sure, and I was, my team was there 24/7 as well, just to make sure that if they had the smallest interruption, we were there immediately to take care of it. And we're talking, 5-10 minutes of a phone call to call support. That wasn't good enough. We had to have people on location ready to go. And that was just for minuscule things, supporting them in monitoring the well bores. So this system is actually enabling to them to monitor the well bores faster and respond faster. At that place, we had 15 minutes from the time that we saw an alarm until it had to be escalated up to the next level. And at that point, we needed to know what was happening and have suggestions of where to go to next. That is almost impossible when you're pulling from 4 or 5 different systems. You've got to look at charts and graphs on different systems. Some data's here, some data's there, and you've got to put it all together very quickly and get a report out to somebody within 15 minutes and have all these conversations too. So a system like this that can look ahead, help you fill out that report, help get that information gathered together, and in addition to that, give some idea of what might be going on, where we can go from here, and additionally log everything that you're doing, keep a record of why you're making these changes, what you're doing, and to be able to look back at that for lessons learned. That's huge to me, and I think that most RTOCs will see a huge benefit in that.
So Jeremiah, do you see a real advantage then from an IT standpoint of being more than just semantics, of having both a watch system as well as an alarm system?
Absolutely. Absolutely. I think that right now you have alarms, and as everybody's kind of alluded to, they're too little too late. Mm-hmm. By the time it's gone off, it means that something bad is already happening. And so now you've got to play catch up, figure out what's happening, and try to troubleshoot that issue. A watch will come in advance and give you an idea of what might be coming based on the conditions that exist at that moment. So it lets you get ahead of the problem. It helps you start making plans with your team, actually discuss that issue and have a really good conversation instead of just always catching up, always trying to get ahead of the problem that's already careening out of control. That's massive, I think.
There's also an issue of consistency that we haven't discussed yet.
That's true.
You have people there 12-hour shifts,
yeah.
So twice a day there's a change of people. You've got bio breaks, you've got coffee break, you've got all these things, and you're relying on the human element to identify something. And in my experience of the RTOC is invariably they're always trying to catch up.
Yeah, absolutely.
They're always trying to catch up, and that's a huge difference. When you have a consistent system running around the clock that doesn't need to leave the room, that doesn't need to have a coffee, doesn't have to have a cigarette, whatever you want to say, right? You then, the team starts to expect that consistency and rely on that consistency. And when you do have an alarm, then it's got some gravity to it. People understand that, all right, because the system is consistent, because it's 24/7, this is one we can't ignore.
Builds a level of trust that they can just attach to, basically.
Mm-hmm.
So that's good. And you kind of reference a level of cognitive bias that becomes natural, I think. You're watching these wells over and over, and a lot of these guys have 10, 20 years plus experience, and they've seen everything. So a lot of, and usually that's great. But sometimes they see something that they've seen before over and over. And by the book, that's a problem, and we should stop and take a moment to look and see what's happening. But because they've seen it so many times, they say, well, this isn't really a problem. I've never seen this escalate.
We didn't have that problem in the last well, so we're not going to have it here. Right?
Exactly.
That's the bias that you don't have.
Let's save some money.
And I wrote an article on that. It's called Perception versus Data.
Yeah.
It's your perception of what should happen, what's going to happen, but here's the data, and your perception is directly opposite of what the facts are telling you.
Right.
Yep.
Right.
So let me give you an example, Jim, a really good point of the difference between perception and reality. That was a very unfortunate blowout in Oklahoma, in which 5 people ultimately perished. And 2 wells were drilled. The first well was drilled significantly underbalanced and nothing happened. They did have an out of balance trip. They were aware of it. And essentially they extended exactly those same practices to the second well. But it just happened to also be a bit of a different pressure regime. And so what we get into, if we take a look at this slide, is there was a system of escalating events over not 1, 2 hours, a few hours, the trip, but 3 days. The well was significantly underbalanced. The mud weight was too low. Gas levels were increasing. At a point while flowing, the pump pressure at constant stroke rate also began to decrease. So then it was a free-flowing well with a straight to the mud gas separator. And eventually during the trip, and I'll abbreviate that, but the trip was out of balance, material balance, from the time they left bottom. So that when they finally got out of the hole, only one thing could happen. Now the blowout was blamed on the blowout preventers. But you see, that's a misperception in the industry. That was merely the tipping point of a series of events that began 3 days before the blowout actually occurred. So again, when you relate to a proactive system, that's what we're about.